Alright, so in this video, we'll be looking at question 3 of 9618, variant 41 of November 2025. And this particular question comes along with a source file called hashtable data. And I have the file right here in the folder in which I have my solutions going on. And you see that this is the file right there, is it? So you can see the file contains a couple integers as well as some words. So let's go ahead and look at the question in more detail. So here we are told that a program stores records in the 2D array called hashtable. Each record is stored at a specific index of the array that is calculated using a hashing algorithm with the records key field. The array is 100 by 10 elements. The hashing algorithm uses the key to generate an index between 0 and 99 inclusive. If two key fields generate the same index, there is a collision. Any records that have a collision are stored in the next space in the same index. For example, in this table, 2 record keys generated the same hash value of 1. 4 record keys generated the same hash value of 3. So you see that right here on row index number 1, you can see that this record entry generated the same hash value of 1, so they are stored in consecutive spaces, as it were. And it also happened for this case whereby they generated the same hash value of 3, and you can see the records they have been stored. The 4 records have been stored in consecutive slots right there in the hash table, as it were. So let's go ahead and look at the first part here, which requires us to declare that class. So we're given a class diagram. The class is called record, and we are supposed to declare the class which has 2 attributes as well as 1 constructor, or rather a constructor. So the attributes are key and data, and these are public. So we are going to write program code that's going to declare the class record in this constructor. Use your programming language appropriate constructor. Let's go ahead and look at the implementation that I have going on here. So you see that, let me zoom in one more time. So I have my implementation going on at lines, between lines 4 and 7 there. So you can see that we have the class definition on line number 4, then line number 5 with the constructor definition. As always, we are putting self as the first parameter. This is mandatory for class methods. And then we have the 2 other attributes, which are namely key and data. And right there on line number 6 and 7, you will notice that we have those public attributes, and we're just indicating that they are public because we didn't put a leading underscore inside, or rather before the attribute name, as it were. So remember, if you put two leading underscores, that's going to mark your attributes as private. But if you just put them like this, it simply means that they're going to be public. So of course, you go ahead and copy this code and paste it inside of the evidence document. Alright, so moving on to, maybe I can close out of this hash data, or just switch to this one. So moving on to the next aspect here, we are going to look at B. So the procedure initialize hash table initializes each element in the array to an empty or null record. Write program code to declare the global 2D array hash table and the procedure initialize hash table. So here we have the first part rather is actually to declare or to have the global 2D array called hash table, right? So what I did in my case was to declare it inside of my main program, or inside of my main method. The reason why I did this was because I could actually put it in the file outside of any class or outside of any method. But to keep my code clean, I actually put it inside of main, so that any other function that I call within main has access to that particular hash table variable on line 68 there. So you can actually see that we are just declaring a variable called hash table, and we are assigning it a value of none right there on line 68. But we are not worried about initializing the 10 by the 100 by 10 aspect of it, because that's actually the job of the initialize hash table function that we have right there on lines 10 through 18. So on line 10 we have the function header, which is the definition as well as the variable name. Then on line number 11 we are using the global keyword for the function to know that if it wants to look for the hash table value, it's going to have to look underneath the caller. So in the case of initialize hash table, since it's going to be called within main, it's going to look for that hash table variable inside of the main function. So on line number 13, we are using list comprehensions to declare a 2D array, as it were, or a 2D list, as it were. So you remember that from list comprehensions, first we have an outer list, then we have an inner list, is it? So the outer list is essentially going to enclose the inner list. Then inside of the inner list, what we put here, so for none, it's going to be the default value that we want our list comprehension to have. So all the slots inside of our list comprehension are going to have a value of none. Then this loop, essentially, it has a nameless variable right there, or rather a throwaway variable. We're just using an underscore. So it's just going to initialize a column, 10 columns, as it were. Then for the rows, it's going to be actually 100 rows right there. That is for the other loop or the outer loop that we have inside of our list comprehension. So this is how you actually can make use of list comprehensions to create 2D data inside of Python. So of course, having done that, you can go ahead and copy the code and paste it inside of the evidence document. Then moving on to C, you see that we have the function called hash, which takes an integer key field as a parameter, calculates and returns the hash value of the key field. Then the hash value is the result from the key, from the formula rather, key mod 100. So we have to write or to implement code for the hash function right there. So I have that going on between line 16, or rather on line 16 and 17. We have the function definition, and it's going to take a parameter called key, and then it's simply going to return, according to the requirements there, it's going to return the result using the formula key mod 100. So the key that we supplied is an argument. It's going to be used to calculate the hash function, as it were. So we are saying the key mod 100, then we return that value right there using the return word on line 17. So of course you go ahead and copy this code and paste it inside of the evidence document. Then moving on to D, we have a procedure called insert data that takes an object of type record as a parameter. Then it also calculates the hash value for the parameter using the appropriate function. Then it's also going to store the parameter in the correct position in the hash table. Then you can assume there will be no more than 10 objects that generate the same hash value. Write program code for insert data. So let's go ahead and look at that implementation going on there between lines 20 and 31. So line 20, we have the function definition there, and it's going to take a record, a parameter of type record rather. Then on line 21, we want this function to make use of the global hash table that we declared inside of the main function. So when this function is called later on within main, it's actually going to look for this hash table within the main function, is it? Then on line 22, we are using the hash function to calculate the hash value for the record that we supplied as an argument. And notice that since the record is actually an object, right, it has that key attribute which is public earlier on that we declared. So we are actually taking that record's key and passing it as an argument to the hash function. Then we are storing the result inside of this hash value. Then we move on to line 25, where we have a loop that's essentially iterating through the 10 columns. Then for the row on which or in which this particular record is going to be inserted, we are using line 26 right there. So we are checking to see if the hash table using the calculated hash value, right, that's going to be the row, then the I, that's the column. So if that particular slot has a value of none, it simply means that that space is available for us to use. So we can go ahead then on line 27 to take that record and store it on that particular slot inside of our hash table. Then of course we can return true because we were able to insert that value inside of our hash table, as it were. Then in the event that we are not able to insert anything, then this return false is going to be returned. Otherwise the function would have already returned true if we were able to add that record, as it were. So having done that, you can go ahead and copy the code and paste it inside of the evidence document. Then moving on to E, we have the file hash table data .txt that stores 200 key values and string data items in the format key and string. So let me just come back to the file here so you can see what they are saying right there, that in the case of 237 right there on line 3, this is actually the key and this is the data as it were, is it? So that's what they are saying right there. The string is the data and the key is the key that's going to be calculated using the hash function. So that's what they are saying right there. So the procedure read data, it's going to open the text file and reads each line. And it's going to split each line into the key and the data. And it's going to call insert data with an object containing each key and matching data. So we have to write program code for read data. So let me go ahead and look at and show you guys what I have going on for my implementation here. So my solution spans between lines 34 and 50 there. So line 34 is your standard function definition there. Then on line 35, since we are going to be working with files, you would want to wrap them inside of to wrap the content or the logic rather inside of a try except block. So inside of the try, we are going to open hash table data in read mode right there as a file. So we are going to, with the file open, we're just going to call it file easy so that we don't have to use the entire file name right there. So we are now saying for a line inside of the file, right, we are going to take a particular line and strip it of any trailing spaces and store that is the modified line. Then if the line so if the line is valid, meaning to say that the line is not empty, right, we are going to go on right there on 41, line 41, and split it where we have a comma there. So in the case of let's say if we had read this line called 237 comma close, we are going to look where there is a comma and we are going to split it into two parts. So we have the 230 the integer part, or rather the first part which is 237 and the last part which is cause. So if the length of parts is equal to 2, it means that we were able to split our data into a key and some data. Then we are going to take the element that is in the parts array right here, or the parts list as it were, the elements that is at index position 0, which should be the key, and we store it inside of the key. But notice we are also typecasting it to an integer on line 43 there so that we store it as an integer value. Then the data, we are taking the data right here, which is inside of the parts array at index position 1, or the second index position as it were. Then we are storing that inside of the data. Then on line 45, we are then passing those two pieces of information as parameters to the record constructor right there on line 45. So we take the key and the data and we instantiate a new record. Essentially, that's what we're doing on line 45 there. Then on line 46, we are inserting that record inside of the hash table using the insert data function that we created earlier on. Then of course, that is the logic right here. Right? It might seem overwhelming, but really we are only doing about 4 or 5 things here. First, we are opening a file. Then we are checking to see if the current line is something that we can read. Then if it is something that we can read, we are splitting the information into 2 and storing it inside of what? Inside of these parts list right there. Then we check the length of the list to see that it has 2 elements within it. So if it has 2 elements within it, we then move on to split the parts respectively to key and data. Then we use that key and data to create a new record object. Then we insert that record object into the hash table right there on line 46. So it's really not much going on. There's really not much going on there, though the code might look like it's complicated. It really isn't that complicated. Then on 47, we are raising an exception. In the event that we do not find the file, we can just print out that the hash table data file has not been found. Then in the event that we were unable to pass any of the data, let's say we weren't able to convert the integer, the string into an integer, right? That is for the key. We just specify that there was an invalid data format in the file. So that is the read data function right here. So you can go ahead and copy this code and paste it inside of the evidence document. Then switching to the question here, rather the question, not the text file. So I think I can, yeah, maybe I will leave it open for now. We want to go on and do the implementation for f here, which is the get record function. So it takes an integer key field as a parameter. Then it also calculates the hash value for the key field using the appropriate function. Then it searches the hash table for the record with the matching key, and it returns the data for the record if the record is found. Otherwise, it returns not found if the record is not found. So we have to write program code for get record here. All right, so going to the solution, you can see my implementation between lines 53 and 63 there. So on line 53, we have a standard function definition. And on line 54, we are referring to the global hash table variable. Remember, this is inside of the main method, right? So it's going to look for this hash table variable inside of the main method. Then on line 55, we are calling the hash function to calculate the key that was supplied to get record, and we store that as the hash value on line 55 there. Then we need to search through the rows for a matching key. So we are using the outer loop right here, or rather this loop to iterate through the columns that we have going on for our hash table. So we are saying that if for the hash value that is specified here, if it is matched with the column that we currently are on, if we are going to store that inside of this record right there, is it? So if the record matches the current, rather if the record is not none, meaning to say that if it is not empty and the record is equal to the key that was supplied by the user when they call this get record function, then we are going to return that particular record as it were. But notice that record is actually an object, is it? So we are saying record, which is an object, then we're using the dot selector to select the data for that particular record as it were. Then on line 63, we are ending a situation whereby we are unable to return some data, so we can simply output not found there. So of course you go ahead and copy this code and paste it inside of the evidence document. Then on part G, we have the main program that's calling initialize hash table data, initialize hash table and read data respectively. And it's going to take 5 integer key fields as input from the user. Then it's going to call get record with each input and outputs the return value. Then we have to write program code for the main program that does those 3 things. So let's go ahead and look at the implementation that I have going on here. So my main method is right there on line 66 to about line 87 there. So you notice earlier on, this is for part B, you will be familiar with this. So on line 71, that's where we are actually initializing hash table data to a 100 by 10 grid or table as it were. Then on line 74, we proceed to populate the hash table variable or hash table 2D list with data. Then in order for us to get input from the user, we actually have to store the inputs somewhere. Initially this was, we actually have to store the input somewhere, right? So what I did earlier on when I was doing this solution, I was actually appending it to, but I don't think I really need to do that anymore. Anyway, it's fine. Maybe I can just comment out of this. Alright, it's fine. Let me just leave it like that. But I don't think if you are going to copy this code, you actually don't need this inputs value right there. But you can just put it on the same. It doesn't really matter. I was tinkering with a different implementation before I started recording the video. But anyway, we want to iterate, or rather we want to take 5 inputs from the user, right? So what we're going to do is we're going to try and take user input, right? Then we concatenate, rather we typecast that input into an integer and store that inside of this user input variable right there. Then the result is going to, rather we're going to call get record with the user's input, which is essentially a key, and store that inside of result. Then we are going to print the key as well as the result. So if we, let's say we had typed in 528, we would actually get 528 and the result, which is permission according to the hash table right here. All right. Then we have an except we have an except clause going on there. In the event that the user tries to input something that is not a valid integer, then we are simply going to output to handle that exception there. But this part really is actually optional. You can actually just leave it here and it would still work as it were. Then here, the I plus right there, we're using format printing, so that for integer 1, i's column is going to be 0, so it's going to be 0 plus 1, which is 1. Then when I is 2, rather when I is 1, it's going to be 1 plus 1, which is essentially 2. If you check out my video on format printing in Python, you actually see that format printing can actually help you evaluate statements like these when you're actually rather at runtime, as it were. So of course, this is how we are getting the 5 inputs from the user. Then you go ahead and copy the code and paste it inside of the evidence document. Then on the next part, we need to test our program using the 4 input values that are given right here. So let's go ahead and do that. Let me just pull up the terminal there. Then, yeah, so that I can have the numbers in view. Clear this out, then run the file. So integer 1 is 528. So if we hit enter, you see that the key is 528 and the data is permission. Then the next key it's rather 1128, which is piece. Then 1828 gives us precedent, and then 1062 gives us up. Then lastly 39 gives us not found. Then our program terminates as it is. So of course you go ahead and take a screenshot of this output and paste it inside of the evidence document. So yeah, I think that's just about it for this video. I hope you picked a thing or two, and I'll see you guys in the next one.